Hi everyone, welcome to Solar Integrations. In today's video I'm going to be connecting up one of these, which is an ESP32, together with an RS485 board to my solar inverter using ESPHome, and we're going to be loading some code onto this which will query the inverter and send that those production figures through to Home Assistant for us. It was an interesting experience and I did learn quite a few things, so I do have tips at the end of the video which will make your life a bit easier, so please make sure you watch to the end. And if you find the video useful, then please like and subscribe. Do appreciate it. So I think the first question is why we would want to use an ESP32 instead of using our SunSync or SolarMan dongle for getting data from the inverter into Home Assistant using those integrations. The main reason is performance. The ESP32 is able to put a lot more queries through to the inverter than the SolarMan and especially the SunSync integrations. And the reason for that, the SunSync integration is going via the cloud, so it's not connecting to the inverter dongle directly. It's going up to SunSync's cloud server and then putting in a query through the API there. So querying the inverter directly over the RS485 connection is faster, and it allows you to have a slightly more up-to-date readings coming in from your inverter. The other thing is that you're not reliant on your internet connection. So if you want to have a cloudless solution where you're not getting any information over the internet, then this would be a better option for you. Okay, I think the second question is going to be, how much is this going to cost? Well, if we look at the ESP32 Dev Board is, if we have a look at from Micro Robotics, 128 Rand for the board, and the RS485 module is 22 Rand. So pretty cheap, about 150 Rand and a bit of time. As far as skills are concerned, it's preferable to solder it up, but you can use jumper cables like this over here. You need 4 of those, so you can purchase those as well from Micro Robotics. I will include some links to their site with the links to the products that you require from them. Okay, so this is a diagram of the wiring diagram for the connections. It's very, very simple. As I said, you can either solder it with a soldering iron if you're able to do that, or alternatively you can just purchase the jumper cables when you get the products. I'll include a link to that as well. And the only other thing you will need is an Ethernet cable. You can either crimp your own up if you're able to do that, or you can just cut an existing Ethernet cable in half and use that for the connection to the inverter. Okay, how are we going to be connecting the ESP32 to our inverter? Well, there are, depending on the inverter that you've got, the SunSync 5 kilowatt or a Day 5 kilowatt or 3-phase, they all have their ports in different locations. They all say RS485 on the top though. You can see this one, Modbus RS485. That one connects over there. There's a few different ways. So what you're going to need to do, that one would connect over there where it says RS485. Some of these ports are for your BMS connections to your batteries. Some of them are for paralleling. You basically look for the RS485 port. If you're struggling to find the right port, then give us a shout on the Powerforum. I'm going to include the link to the thread on that, and the guys will be able to help you out there as well. The pins that we're going to be using are pins 1 and 2, so we're only going to be connecting using the orange and white and orange, or you can use pin 7 and 8, which is the brown and white brown connections, and that is the pins that we're going to be using from our Ethernet cable, which we've cut in half. You do need to check that pinout, which you can see over there, is with this tab facing away from you. So when you look at it, it'll be pin 1 and pin 2 will be on the left hand side, and pin 8 and pin 7 are on the right hand side, and you'll be using, I usually just use pin 1 and pin 2, so that's orange and white and orange. Okay, the only other thing you have to be aware of is that on the RS485 board, when it's connecting to your inverter, the connection to the inverter has to have a terminating resistor on it. Now, some inverters seem to have that built in and some of them don't. I'm not sure, maybe if anybody knows exactly what the situation is, you can comment in, can put something in your comments. But if you have a look on the board very closely, I don't know if you can, I don't think it'll focus that close, but there's a R7 on the board, and you may need to take that R7 off. What I would do is, if you can see on that one over there, I've taken the R7 off. You just heat it up with a soldering iron and on both sides, and then you can just wipe that resistor off. That's the terminating resistor for the RS485 connection. As I said, try it with it on. If that doesn't work, then I would take it off, and most of my ones have worked with it off. I've had on a SunSync 8 kilowatt and now on my day 16 kilowatt inverters. But try it with it on first. If it works with it on, then don't worry about it. Okay, so now we want to get to installing ESPHome on our Home Assistant and setting all that up. I've got my board set up over here with my cables. I've got orange and white, depending on how you look at it. Orange and white going to the one on the left, the orange to the one on the right. So that's pin 1 and pin 2 from here. And we're going to be installing ESPHome onto our Home Assistant, and then we're going to be taking the code from SlipX06's SunSync Day Home Assistant dashboard, and we're going to be using his ESPHome YAML file from there, which I think works really, really well, and I'll be showing you how to set that up. Okay, so we're going to be installing ESPHome now. Go to Settings, Add-ons, Add-on Store, search for ESPHome. There it is over there. ESPHome. Okay, so now ESPHome we can use for all sorts of other all sorts of other uses for it as well. We can create our own smart devices, and I use it for reading the temperatures from my solar geysers. It's really, really useful little add-on, especially when you've got something which is a little bit more proprietary. So the first time you want to use your ESP32 with ESPHome, you have to onboard the ESP32 into ESPHome, which what it does is it loads a basic configuration onto the ESP32 and associates it with ESPHome and loads the Wi-Fi on, so that any updates that you do from then on, you can do over Wi-Fi. So what we're going to do is we're going to go to the web interface, and we're going to tell it that we want to add a new device. We're going to use ESPHome Web for that, which is this over here. Now, the first time you connect, your system may have the drivers, it might not have the drivers. If you click on connect and you don't see your ESP32, then you'll need to install the drivers. I'll include a link for when when it is connected, you will see it'll say usually a CP2102 interface. You connect to that and you tell it that prepare the ESP32 for first use. So we're going to go ahead and tell it to do that. This takes about 2 minutes to do. So my ESP32 is plugged into my inverter and it's connected to power into the RS485 port. I see it's just gone offline. Let me click on logs and see, okay, it's come back online again. Let's see what it says in the logs. There, it's connected. It's going through everything, how much noise it's getting, and it's getting data. So that's all looking good. If you're not getting this, I'm going to have some tips for you. So stay tuned on that as for things to check. What you can now do is, if I go into settings, integrations, my system seems a bit slow. Okay, let's discover it on the, okay, so there it's found my day 2. It's called day 2 because I did have a day 1 already, so it's just added that on. If I click on configure, it's going to add those settings onto Home Assistant for me. I need the encryption key. Okay, so I'm going to need to get the encryption key from ESPHome. If I go to edit and I go my encryption key, I can just, oops, copy that, go back to settings, integrations, configure, put in my key over there, go submit, okay, and I go finish. It's now seeing it. It's called device inverter ESPHome. Seeing the 76 entities, and there's everything that's reading from the inverter. That's the 76 different values. What I'm going to do is just create a new dashboard. I'm going to call it okay, there it is there, ESP32. Go into the ESP32 dashboard. Okay, and I'm just going to go edit dashboard. Let's delete this other stuff out of here. That's energy forecast. Let's just delete this out. Okay. And then what I'm going to do, click on done. Okay, so this is a nice clean dashboard. I've taken all my other bits and pieces off there. If I go settings, integrations, onto my inverter, and I tell it I want to add that to the dashboard. I want to add it to my ESP32 dashboard. Yes. Add that to dashboard. Add that to my dashboard. And add that to my dashboard. Okay, so if I now go and have a look on my ESP32 dashboard, I've got these for setting my time, my battery limits in my time zones. This time zone value will change depending on what you've got. Those are your 6 time zones. You can customize this for whatever you've set your time zones for. You can charge your grid charge if you want it to charge from the grid during those, and if you want it priority load or priority battery. And here's all your values over here. So this is a very basic dashboard. In my next video, I'm going to be covering how to create, how to load the dashboard from SlipX 06 He's got some great features, so make sure you like and subscribe for that. Here's some of the dashboards which we're going to use that data to create. You can have a look over there. It's with solar forecasts and all sorts of things. So I'm going to be going through that in my next video. If you do find this content interesting, please like and subscribe. It does help my channel, and I've got some really exciting stuff coming up, and we'll leave your comments, please. Thank you very much. If you're not getting your data into Home Assistant, but you've loaded the firmware and everything on, the things that you want to do is to check that you've got these connected up properly. This D4 is the flow control, so that needs to be on number 4, and you've got 17 and 16 are your transmit and receive pins. If you have a look on this diagram over here, there you can see 17 and 16 are transmit and receive, and GPIO4 is for flow control. I know that SlipX06 does, in his defaults are for are using pins 1 and 3. So his ones are using pin 1 and pin 3, which are those two over there, and then pin 4 for flow control. You can do it either way. If you would prefer to wire it up that way, it's totally up to you. This diagram though is for 17 and 16. So you want to check that. And then the second thing to check is that you have these cables wired the right way. SlipX06 is, or this original diagram is for a T56A connection, in which pin 1 and pin 2 are green and white. If you've got a T56A, a T56B Ethernet cable, then that is going to be orange and white and orange. So just check that you've got that cabled up, that you've got that wired up correctly. You'll know it's a T56B because the cables, if you look at it from left to right, it'll be orange and white orange, green and white blue, blue and white green, brown and white brown. And those are the most common cables. So it's probably orange and white orange that you want to connect up. And other than that, it's pretty much, I would just check the connections. If you've soldered it, check your solder connections, or if you're using just push-on connectors, just check that everything's pushed on. Unfortunately, this thing doesn't have a light in it or anything, so you don't know that this is working or that it's receiving data, but it's usually pretty easy. So good luck, and let us know if you get stuck.